Hello, statistics student. This video is for chapter 2.5 and 2.6, measure of center. So in the last video, we calculate mean and median using the LibreText one variable statistic calculator, and we discover that mean is not resistant, whereas median is resistant. So the second example that I'm going to do is find the mean of top 5 scores of a class. So a class has a lot of grades, and these are the top 5 scores, and I just want to find the mean of the top 5 scores. So in this case, I'm going to not use the LibreText one variable calculator. I'm going to use this. So because I have typed the data into a column, so I copy the top 5 scores in my column, and I just cut and paste into this that is empty. So if you have anything, you can clear it, and also clear your browser or reset your browser. Okay, so Control V to copy it in. So now if you have those number, like just show you, if you are trying to copy a comma list into this, it won't work. So let's say you copy it and you go into this, paste. It doesn't work. Let's see, if I do Control V, would it work? It still doesn't work. So if you have the list of commas, it's best to use the LibreText one variable statistics. If you have a um, column, then it may be easier to use the this. So you do data, explore data, descriptive statistics. So what you do is you want to calculate all of the descriptive statistics, one of them being the mean. So after you enter your data, you do data and then select the descriptive statistics, and you have to tell which column you want to do. In our case, is column 1, and you hit evaluate. The median is on this side. So they have some histogram here and box plot here, but these are none of those that we want. The histogram, you cannot adjust the classes. The box plot is not a modified box plot, so it's not that particularly useful. If you want a meaningful histogram and box plot or modified box plot, you actually go here. Okay, but they give it to you. So let's see what our mean is, 92.8. Right, so that's what I only want. So I would say this is just top 5 scores. Of course, it's just a sample. It's not the whole class, right? So X bar is 92.8. So the second part of this question is, can this sample mean, be used to estimate the mean of the whole class? Can I? Of course not. So the one thing you can do is the sample representative? Is it a random sample? Does it have a good size? So representative. So it is not in both. First is just top 5, so it's not randomly drawn, and also you only have 5 data. So I think the main important thing is it's not a random sample. Okay. If it's not a random sample, it would not be appropriate. And it actually just the top 5 score. It's, of course, this would be higher than the actual mean. Okay, so no. Okay, so you cannot use 92.8 to estimate for whole class mean. So the third example I want to do is just have a larger data set that's in comma form, right? So, and I want to calculate mean, median, mid-range, and mode, all of them. So let's try to do this. So I'll copy them, so see if it works. Because they are in comma lists, I'm going to do the one variable statistic calculator, clear this first, and then paste it in. Yeah, it pays okay well. And then I just do calculate. So mean is 27.3. So just put it here. Oh, not enough space. So 27.3. Median is 27. These two numbers are quite close, right? Mode is a little difficult. I can't really find it over here. You can see that it is so difficult to find. You can kind of look at it and circle the number. Well, there's is 27 and 27 and 27 that happened 3 times, but do I have other data that happened 3 times? I really cannot, because I didn't. Oh, there's a 25 that also have 3 times, right? So maybe Maybe one of them is, I don't know. So we need some other way. And mid-range would be the maximum and minimum divided by 2. Our minimum is 16, the maximum is 40. So 40 plus 16 divided by 2. So that's 56, so that's 28. But I still don't know this one. I can use the other calculator that I have. What is it? Calculator soup or something. But I'm going to show you how I can actually do it also here. Let's clear the browser and then also clear all these first because I have a set of the data, the boat length, right? So it is a rather large data set, so I copy it, but I have it typed up. So I just do paste it. After I paste it, then I will, if I want to find the mole, that's what I'll do. I'll do the data tools. I sort them. Okay, I don't sort all the column, just this one column, column one column, column one, and from largest to smallest or whatever. So the smallest number is 16, and then you can see that they're all sorted in order. So you can go through them. Oh, 25 has 3. Because they're sorted, the similar number will be together. 3 is 25, 3 27. This is only 2, so it doesn't count. So yes, that's our mole. So we would have 2 mole, both 25 and 33, right? But you can find it by sorting them. So which one is the best measure of center? So both mean and median are kind of, do we have extreme data? We don't have extreme data. So we would say both mean and median are quite good. And if you have a choice, then you use the mean, okay? Because the mean is easy to understand. It has a formula. Can you use it to estimate the mean length of all the boats in all marina? Well, this is just in one marina. We will say no, this is only one sample, right? Uh, so these boats are only parked in one sample in one marina, so it doesn't represent all boats in all marinas. Okay, so the sample is not too representative. Your sample size is not good enough. Oh, actually, I have my answer here. When data is symmetrical or no outlier, we use the mean. Okay. We don't know if it's symmetrical, but in this case, there's no outlier, so we use the mean. You can tell the mean and median are more or less the same. Yeah. The next things we want to talk about is mean and skewness. So skewness describe where the highest data, the most frequent, or most not frequent, the most representative data, is it in the high end of the data set, or is it in the middle, symmetrical, or is it on the low end? Okay, so we have name for these kind of data set shapes. So first is skewed to the left. This is symmetrical or normal, and this is skewed to the right, right? So, but you can see if it is skewed to the left, the median is still in the middle. The mean is always following the high number. Oh, well, in this case, the low number. The mole is the one in the peak. So the median is between mean and mole. When it is symmetrical, mean, mode, and median are all the same. Whereas if it is a right skew data set where most of the data is in the low end, then the mean go to the high side because the mean follow this extreme rare data. And then the median is kind of in the middle, and the mode is at the peak. So what is the best measure of center? The best measure of center is if there is skew, the data are skewed, both of these, um, you would use the median if extreme data exists or data is skewed. And if the data is, symmetrical, it's the same as the median, then I would use the mean because it's easier to manipulate. It has a formula. And we use mode usually for nominal data or categorical data. Okay, so do some example. What is the best measure for the data? So if I have a data that is 7, 8, 10, 25, 35, 33, and then 100. So what is the best measure of center? I would say the best is the median because 100 seems to be very extreme, right? Because extreme data exists, outliers exist. See? So when you see things like this, you will say the median is better. Okay. Or if someone graph some data and the shape is, the shape is left skew or right skew, then you say use median. But if it's a symmetrical data, you would use the mean. The second topics that we're going to talk about is what about if I have summarized data? I don't have the original data set, but they are summarized in the frequency distribution. How do I still find the mean or estimate the mean? I don't think it is actually the mean, but it is an estimated mean. Okay. So the way to do it is the formula is sigma f times x divided by sigma f. That means you will multiply x, which is the midpoint of each class, because we're talking about frequency distribution, and then f is frequency of each class. So basically, if you have a table like this, so you know that these are grades for class 50 to 59. There's one student do really not very good. Most of the students get 90 to 99, and here 5 students, 80 to 89, 4 students. So there are 4 grade in this range. The actual data are the grades. These are frequency. So if I want to find mean, I don't mean to find the mean of the frequency, right? These are just count how many data are there. I actually want to find the grouped mean or the estimated mean. So we can think about this as I have one data from 50 to 59, but where is that data? If I want to find the mean, I need that data, but I don't. I only know that it's between 50 to 59. So what we can do is just use the midpoint. I'll write the midpoint here by finding 50 plus 59, lower limit plus upper limit divided by 2, right? 50 plus 59 divided by 2, so 54.5. This 60 plus 69 divided by 2 is 64.5. 74.5, you can get the idea. That's a pattern, right? Because they differ by 10, so 94.5. And then this is a frequency, so you just pretend that there is 154.5 times 1. No 64.5, so this you don't need to count it. Then there's 274.5, so this one I don't add, so I would have 2 of this and 4 of this and 5 of this, and then I add them together and divide it by the total frequency. So the total frequency is actually sigma f is actually right 9, 10, 12, right? 12. So I would have to write them together if I do it by hand. But I don't have to do it by hand. So by hand, you can actually still do it. You can say 54.5 times 1 plus 64, we don't use. 74.5, there's 2 of them, plus 84.5 times 4 of them, plus 94.5 times 5 of them, and divided by 12, because I don't just have 4 data, I have 12 data. So that would be the mean. Okay, do it by hand. But you can also do it by a calculator with LibreText. LibreText has a calculator called LibreText frequency calculator, frequency table calculator. Okay, so yeah, mean and standard deviation for grouped frequency. I think this is the one. Yeah. So what you do is you enter the midpoint. You have to calculate the midpoint, 54.5. So the way to do is 54.5, 64. No, 64 I don't need to because it's 0, right? 84.5, 94.5. And what is the frequency that I have? 1, 2, 4, 5. So 1, 2, 4, 5. It's 0. You can skip. Then you just do the calculate is at the bottom. Calculate. So make sure you have 12 sample size, and the mean is 84.5. Okay, so that is the mean is 84.5. So that's how you calculate the mean from a frequency table.